This video demonstrates accessibility and inclusion features developed in the Nevrolens Augmented Reality application following the guidelines provided in the Code of Conduct of the XR for Human project funded by the Horizon Europe program of the European Union. The XR for Human Code of Conduct sets forth ethical obligations for developers involved in technological innovation and governance of immersive technologies to ensure that these technologies respect human rights, protect user privacy, promote inclusivity, and safeguard the mental, physical, and social well-being of all users. The code contains 10 guiding principles. In our work, we followed the principle of diversity, inclusivity, and accessibility, which advises to design immersive experiences that are inclusive and accessible to as many users as possible, considering their intended use. Ensure that experiences also cater to the special needs of marginalized and vulnerable populations, including people with disabilities and the economically disadvantaged. The other principles are safe experience, equitability, privacy and data governance, identity and right to anonymity, human-centered design, trustworthiness and transparency, sustainability, technical security and interoperability, and risk management and moral dilemma resolution. The Nevrolens app provides an augmented reality experience for learning about the neuroanatomy of the rat brain and the human brain. The app can be used by medical students to learn neuroanatomy as part of formal education or informally. The brain models appear in the augmented reality space. The users can rotate the model, move it, and scale it like this. The app also allows to simulate a dissection of the brain models, still in the augmented reality space. The user can choose sagittal, coronal, horizontal, or custom dissection plane. So here are the accessibility and inclusion features developed. First, most of the user interface has been redesigned for screen space, evaluated with end users, and further improved based on the feedback. The user interface is high contrast, with large fonts used for text elements, following the accessibility standards and best practices. An integrated and optional tutorial provides the user with the necessary guidance to comfortably use the application, covering the most common misconceptions and needs in the use discovered in user testing. The tutorial includes the understanding of the augmented reality space, the manipulation controls for the entire brain model, manipulating the individual sections of the brain model, and accessing the information about these sections, including the text-to-speech feature. Information about the different parts and sections of the brain is available as text. Interacting with a specific part of the brain in augmented reality space will display its name in the bottom panel of the app, which then can be extended to get a more detailed description. Furthermore, by tapping on the text-to-speech button, the user can listen to the same description.
The granule cell level of the cerebellum is located behind the forebrain hemispheres, on top of the brainstem, connected with the brain through 3 major axon bundles.
Here is another example.
All vertebrate animals have spinal cords. Phylogenetically, it is the oldest part of the central nervous system, CNS. In contrast to the more recently evolved cerebral and cerebellar hemispheres of the brain,
The speech can be stopped at any time by tapping on the same text-to-speech button again. And one more example.
The olfactory bulb, Latin bulbus olfactorius, is a neural structure of the vertebrate forebrain involved in olfaction, the sense.
When working with both rat and human brain models placed in the same augmented reality space, the user can interact with their parts and sections at the same time and in the same way. For example, like this.
The molecular layer of the cerebellum is located behind the forebrain hemispheres on top of the brainstem, connected with the brain through 3 major axon bundles. The outermost layer of the brain, responsible for higher cognitive functions like thought, language, and memory. It is heavily folded, giving it its characteristic wrinkled appearance.